Okay, so we're just simplifying a complex number. We're writing it in standard form, so we're going to multiply the numerator and the denominator by the conjugate. So for my numerator, I'm going to get 12 minus 6i in my numerator. And my denominator, I mean, I can do this two ways. So the long way would be to kind of FOIL that out. So I'm going to have 16 plus 8i. And what did I just do here? I did the inner first. You know, when I learned this, we didn't have FOIL in the old days, right? So I always did inner and then outer. So I'll do your one. Okay, outer and then plus 8i. It's going to go away anyways. And then I'm going to have minus 4i squared. Okay, so my 8 plus 8i and my minus 8i are going to go away, right? You good with that? Yeah. So I didn't make a mistake there? Okay. So I have 12 minus 6i over 16 minus 4, and this is the key right here. I squared is negative 1. Don't forget that I squared is negative 1. So that's going to be 12 minus 6i over 16 plus 4. So I'm going to have 12 minus 6i over 20. That's what I do wrong.
Oh, never mind. Can you scroll up a little bit?
Sure. Yes, I can. Yes, Lola.
What did we mark down if we didn't simplify it?
Yeah, I'm going to simplify it right now. Yeah. Yeah, because I mean, this is, yeah, it needs to be simplified. So I can't divide it by everything by 4 because I have that 6 in there, but I can certainly divide every term in that expression there by 2. So I'm going to end up with 6 minus 3i over 10. And since I have to separate my imaginary piece from my real piece, that is the same thing as 6 over 10 minus 3i over 10, which is the same thing as 3/5 minus 3i over 10. So this is the proper solution to this simplification.
So 10 applies to both? The 10 denominator, like it applies to the 6 and the 3i?
Sure, because if you look up here at the top, you know where I was, right? I mean, I just multiplied straight across. So I had my 12 minus 6i as my numerator, and when I FOIL this out all the way, or simplify it in however way that I'm going to do it, that's going to just wind up to be 10. So it's the same thing as 12 minus 6i over 10, and 10 is the denominator for the entire fraction there.
All right, yeah.
Yes?
Would I squared be 1 because it's negative 1 times negative 1.
Yeah.
Let's not go there.
Yeah. Well, yeah, no, and this is where you have to know that I is different. Okay, because you're absolutely right. If I multiply the square root of 5 times the square root of 5, that looks like it's the same thing as the square root of 25, which is equal to 5, right? Or if I multiply the square root of 3 times the square root of 7, that's the same thing as the square root of 3 times 7, which is the square root of 21. Right? And you would think, right, that if I multiply the square root of negative 1 times the square root of negative 1, that should equal the square root of negative 1 times negative 1, which would be the square root of 1, which would equal 1. But it's not. Don't do it.
This is like
It should be. It makes all the logical sense in the world, but that's why they invented I. Was because you needed to have the square root of negative 1. So the square root of negative 1 times the square root of negative 1 is equal to negative 1. You just have to roll with it. Just have to roll with it. Yeah. The square root of And you just might want to memorize, if it'll help you, you know, the I squared, the I to the third, and the I to the fourth.
Is that on a moto?
I don't think it is, but I can certainly put it there.
It's on the last slide of your,
Oh, it's on the last slide, but I can make it as a separate thing there, yeah.
Yeah.
Margaret.
In 7th grade, when our teacher, like, when she first taught us, like, square root,
Uh-huh.
she, like, instead of telling us to, like, to make it, like, one big number, like, multiplying them together, she would say, like, if you had a pair of the same numbers, you would just circle the inside of one, and then that would be, like, that would be, like, the perfect.
Right, and then you get rid of the radical sign.
Right, so, like, if you had -1 times -1, like, instead of multiplying them, you would just circle one of the pairs, and then that would be, like, your perfect square.
Yeah, that's a good way to memorize it, Madison. What?
You're sorry for it.
Yeah, I know, that's okay, because I thought this would be worthwhile having on there, yeah, thank you, thank you for that, yeah.
So, like, I get the concept of I, but if it doesn't make rational sense that I squared is negative I, then, like, how can they, like, consider that I? That doesn't make sense.
Well, you're just gonna have to,